So I've been interested in this question for a long time. What can deep learning teach us about the unsolved Zodiac 340 cipher? Deep learning is basically a technology that lets us train computers to solve problems. The Zodiac 340 cipher is one of the most famous unsolved problems. And what I was interested in was applying this technology to the 340 cipher to try to maybe come up with some insights about what it might be, how it's enciphered, and maybe one day lead to a solution. In other words, code breaking is really hard work. It'd be really nice if we get computers to help us. This is the Zodiac serial killer, in case anyone's not familiar. I don't know why you wouldn't be. About 50 years ago, he attacked 7 people. 5 of them were killed, and the case is unsolved. The killer is unidentified, and part of the reason he's really famous is because he would send these taunting and threatening letters to newspapers, and the newspapers would publish them. And sometimes he included coded messages. After attacking his first 4 victims, he mailed what's known as the 408 cipher to newspapers, and the newspapers published them. And within a few days, some amateur code breakers came up with the solution to the code. And it was a rambling message from the killer explaining why he was killing people and saying that he wasn't going to give up his name because he didn't want anyone interfering with his crimes. Within a few months, he attacked 3 more people and sent another coded message to the newspapers. Newspapers published this code as well. In fact, in a few weeks, come November 8th, it will be the 50th anniversary of when he sent this to the papers. And this cipher still hasn't been solved. It's one of the most famous unsolved ciphers. There have been many proposed solutions to it, but none of them have been generally accepted as correct. So what did he do to the cipher? It looks a lot like a homophonic substitution cipher because it resembles the first one that he sent. It has a lot of the same symbols. It is written out in a neat grid, a lot like the first one. So it looks a lot like that first one. But people have been trying to solve it as if it's a homophonic substitution for 50 years and haven't come up with any solutions. They've developed software that specializes in solving homophonic ciphers. They've gotten really good at solving ciphers that look like the 340, but they too are unable to uncover solutions. So it seems likely that there's something else going on with the cipher. The killer may have done something to the plain text before performing the homophonic substitution, or maybe he did something after the substitution, manipulating the cipher text in some way to make it harder to crack. Or maybe it doesn't even have a message at all and it's meaningless. I think that he might have done something to the plain text before encipherment, so that's what I'm exploring with my research. This is an example of one of many possibilities. He could have done all sorts of things to the text before encipherment. This is just, you take a plain text message, you write it out into a grid, and then you do a simple columnar transposition, where you read off by the columns, you rewrite the text like that, and then you assign the symbols. So you end up with a cipher that looks a lot like that first one. It looks like a homophonic substitution, but it has this extra step to it. Now, do we have any reason to believe that he did something like this? Well, in the 340, you can find a lot of patterns like this, these repeating patterns, where there's a group of symbols, they're separated by the same distance, and they occur several times in the ciphertext. It has an unusually high number of these kinds of patterns. It's possible that these represent repeating groups of letters in the original plaintext that have been split apart by some manipulation of the plaintext, a transposition, say. So there might be some methodical way of causing these patterns to appear. Another unusual pattern we find in the 340 are these repeating groups of 3 symbols that occur in multiple directions, which is suggestive of a route transposition, say, where the plaintext is written in multiple directions before encipherment. These are hugely mysterious patterns. They're unlikely to be just happening randomly. Another reason to go down this path is the FBI did back in the day when the cipher first came out. In the case files for the Zodiac case, there's a document from the FBI describing some of the cryptanalysis they did, and they explored the idea that maybe he did something to the plaintext before doing the homophonic substitution. They described different ideas that they tried out, but they didn't turn up anything. So that's what we're looking at. We're looking at an unknown ciphering system. We're trying to identify what method is used, and that's the biggest roadblock to solving this thing, right? You have to know what you're trying to attack before you can attack it. So how do code breakers do that? When they're looking at an unknown cipher, how do they figure out what it is? Well, they have to collect clues from the ciphertext. They have to compute statistics. They have to take measurements. They have to run tests. And then they use that information to come to a decision about what the cipher type is likely to be. For example, you do frequency analysis, and that can narrow down the cipher types that it could be. You can compute the index of coincidence, one of the most useful statistics and cryptanalysis. You can look for repeating patterns. This is an example of repeating patterns that suggest the cipher was a Vigenère cipher. And so, this is a lot of hard work just to figure out what the cipher is. And this is just a few simple examples, and there's a lot of different possible things that you can do to find clues in the ciphertext. And then gathering that information is tedious, so we use software in a lot of cases to save time. But then you have to make a decision on all that data about what kind of cipher it might be before you can attack it. Sometimes it's really obvious, and a lot of times it's not. So can we get computers involved to help us make that decision? And that's where machine learning comes in. Machine learning is a way to teach computers to solve problems. And what you do is you have a bunch of examples of the problem that you already know the answer to. And you show the algorithm these sample problems, and you have it guess what the answers are. And it's going to be far off the mark initially. And the information about the difference between the expected answers and the predicted answers from the algorithm are fed back into a training process. And that improves the algorithm's ability to learn the problem and come up with accurate answers. We have some examples of machine learning methods that were used for cipher type identification. These were developed by William Mason. He's an ACA member, otherwise known as Bion. And so he developed two different machine learning methods. One of them is this random forest of decision trees. And a decision tree is basically like a flowchart that you apply to a bunch of input data. And it uses like a series of if-then statements where you go, I'm going to make this choice now based on these values. And during the training process, the decision trees are adjusted until the accuracy of their classifier goes up. The second kind that he made is called an artificial neural network. It's a collection of nodes and interconnections between the nodes. And you expose the network to your input data, and certain nodes are activated, and then it causes different activations in the output, which are interpreted as answers to your problems. In this case, the identification of the cipher systems. And so between these two classifiers, he was able to get a general accuracy somewhere between 60 and 70% on 50 different types of ACA ciphers that often appear in their bi-monthly journal. So it's a very effective way of identifying the cipher types. So I wanted to try to build on that using the neural network idea. And so in my research, I developed a way to generate hundreds of thousands of test ciphers that resemble the Zodiac's 340 cipher, but use a variety of different ciphering systems where the plain text might be manipulated before homophonic substitution is applied. And then all that gets converted into the input data used to train the classifier. And the input data is all these numerical measurements and statistics, index of coincidence, language statistics, and all these sorts of things. And then the classifier produces a prediction about what it thinks the ciphering system is. Was columnar transposition done first before homophonic substitution? Is it purely a homophonic cipher? Was Vigenère done? And so forth. So I tried this with a deep learning software package called Keras. What exactly is deep learning? Deep learning is kind of an extension of neural networks. Artificial neural networks have been around since the 1940s, so the technique has been around for a very long time. But it's only recently that computers have gotten so powerful that you can create really complicated networks, really big networks with a lot of nodes and a lot of connections in between. So the deep in deep learning means that the layers are deep, and so the networks can learn more intricate problems. So there's a lot of really powerful applications of deep learning, such as with image recognition, recognizing human faces, speech-to-text translation, handwriting recognition, self-driving cars, putting the actor Nicolas Cage into movies that he was never in. Apparently this was a problem humanity needed to solve, and by God, we did it. So if it works for Nicolas Cage, surely I could use it with my experiments. So these are examples of the cipher types that I tried to include in the classifier, in training the classifier. I wanted to make it try to recognize these different kinds of ciphers, and then after training, show it the unsolved Zodiac cipher and have it tell me what it thinks the 340 might be. So the first kind is just a straight homophonic substitution, like the first cipher, nothing being done to the plain text initially. Columnar transposition, where you write out the message and read off by the rows or the columns. Diagonal transposition, where you read off the plain text diagonally. And gibberish, which is just randomly selected letters. Because I wanted the classifier to tell me if the Zodiac might just be gibberish, so just random text. Now, when these operations are performed, homophonics is the last step. So these get enciphered. Some other types the L route, which is just read off in these L shapes, which resemble those repeating patterns I showed earlier. Permutation, which is like a variation of columnar. Quadrants, where the plain text is written out into these sections and then read off. And then rail fence, the classic transposition, where you write out the plain text in a zigzag pattern and you read off by rows. And again, all of these, once these transpositions are done, then we do homophonic substitution. And then the snake transposition, where it's like a zigzag pattern through the plain text. A spiral pattern where you go in an inward or an outward spiral, and then visioneer, where you apply a visioneer key and then do homophonic substitution. So the first classifier I trained on those cipher types, I got a 30% accuracy out of them, so not great. It was particularly weak with the transposition types, distinguishing between the transposition types, but it was good at detecting visioneer, homophonic, and gibberish ciphers. So I kept those separate in the next experiment. In the next experiment, what I did was I combined all the columnar type ciphers together and the root ciphers together to kind of make it easier on the classifier to distinguish between the different categories. So the second classifier gave me about a 60% accuracy on the test data. So now what does it think about the Zodiac ciphers? Well, during the training process, the classifier has not been shown either of the first two Zodiac ciphers, so it doesn't have any prior knowledge of what they are. And what this is a chart of the predictions made by the classifier. The numbers on the left are percentages. They can be interpreted as probabilities. The cipher types are along the bottom. So the results for the 408 are these blue bars, and as we would want to see, the classifier does correctly predict that the 408 is homophonic. But for the 340, the predictions are split among several types: homophonic, columnar, and root. So there's some confusion in the classifier. It thinks that there's some mix of encipherment methods going on. But despite its confusion on those, it's giving a very low probability for visioneer and gibberish. So that might be a sign that it's not visioneer or gibberish. I made an even simpler classifier, which only tells the difference between two types, homophonic and columnar. And this particular classifier had like a 90% overall accuracy on the test data that I gave it. And it too correctly predicts that the 408 is homophonic, but again, the prediction is split between homophonic and columnar for the 340. So it's perhaps detecting some evidence of a homophonic substitution as well as a columnar or some kind of transposition. And there's a similar story for the other, another classifier that I trained that compares homophonic to root transpositions. It gets homophonic right for the 408, but the vote is again split between homophonic and root for the 340. And then finally, for the last classifier I trained, it's forced to make a choice between gibberish and homophonic. And in this case, it thinks both of the ciphers are strictly homophonic. So we would rather give the vote to homophonic for the 340 than for gibberish. So again, it's like another confirmation that it might not be a gibberish cipher. So now what? Did we learn anything about the 340? Well, the classifiers were good at telling me what we already know, that the 408 is homophonic. So that gave me a little bit of confidence that the approach has some merit. The classifiers seem to be very confident that the ciphers were not, or that the 340 was not gibberish and not visioneer, but it's confused about whether it's homophonic or one of those transposition types. But that's where we're kind of stuck, because the classifier can't yet distinguish between those different transposition types. And I think that has to do with the input data that goes into the training process. There has to be some information there that the neural network can latch onto and go, okay, this is what tells the difference between a columnar transposition and, say, a rail fence. And so there's some specific measurement that you would have to take and put it into that input data in order to improve the accuracy of the network. In the machine learning world, that's known as a feature engineering problem, where you're trying to extract features from data and then add them in to the classification process, the training process. But there are some other deep learning technologies that can help us out of that mess. There's a type of neural network called a LSTM, which is a way of adding memory to a neural network, so it can start treating input data as time sequences. And there's one called a convolutional neural network, which is really good with image classification problems. And what it does is it automatically discovers small features in an input image, and as it goes through the network, it detects more and more complex features, combinations of features, and it can start to abstract concepts about the inputs. In this case, a vehicle type on an image that it's looking at. And so I think there's a lot of potential there, because what's nice about it is you just give it raw data. You don't have to give it all these custom measurements in the input. So for a cipher type classification problem, you would only have to give it the ciphertext itself. You wouldn't have to give it all of these calculations and measurements. So I think there's a lot of potential there. So I think that this approach has given me some information about the 340. It's made me hopeful that there is a message there, because it's kind of confirmed this hypothesis that that it's not gibberish. And it's also kind of confirmed the idea that the cipher might be a combination of steps. But the challenge will be to do more research to try to figure out how to get it to split the identification of these different root transposition types. So I think that developing this technology is going to help give us more information about the 340 as well as unsolved ciphers in general. Thank you.